Okay, what are some thoughts here? Now, I know on this first, I know you know that x is equal to 5 on this first one. At least I hope you know that that's equal to 5. But again, the y is the more important part. So who can tell me why I know that 10 over 2 is equal to x, or x is equal to 5? Or some thoughts that either you had, or maybe the person we talked to.
10 divided by 2 is 5.
Okay, how do I know that?
I don't know.
You don't know? Okay. Y always guesses. You're right. 10 divided by 2 is 5, but how do I even know what's that mean? 10 divided by 2 is 5.
We have like 10 different like objects or something, or like things, and if you put them in half, then one bit will come back.
Okay, so you can think of it in terms of groupings. All right, so I got 10 things. I can put them into 2 groups, so each group would have 5 items in it. Okay, that's one way to think about
The
it.
fraction can be simplified to 5 over 1
Why?
because you can divide both of them by 2.
Okay, so in this case, in terms of simplifying, we can think about, okay, they're both divisible by 2, which will give me 5 over 1. Okay, that's a good way of thinking about it. Do you mind thinking of it a different way? What would be if I said, okay, check it to make sure that works? Other than just typing the calculator, what's a way we could check to see if it works? What would have to be true in order for x equals 5 here?
1 times 2 equals.
Okay, so the inverse operation would have to be true. In other words, if I'm taking 10 and dividing by 2 and getting 5, then I should be able to take 5 times 2 and get 10 and make sure that works. Okay. Could I use that same idea for the second one? We know x is equal to 4, but could I use that same idea as my reasoning? Yep. We can say, okay, well, 5 times 4 has to equal 20. So that seems to make sense. Okay. What about the last one? The 30 divided by 0 is equal to x. What's x here? And 5, what's that mean? No possible answer. You know what's coming next, right? Why? Yeah, if we followed this same pattern, we said, well, if it really works, I should be able to take this number times the answer, and it should give me my initial value up here. So in this case, I'm trying to take 0 times something and end up with 30, and we know that's not possible with any real numbers, right? So we have an undefined value there. Well, we use that idea, the fact that we couldn't divide by 0 the other day when you guys were starting to do your graphs. So we're eventually going to finish up those posters that you started on Monday. But I want to kind of talk about what we would probably want to have to look at, or what we might want to look at as we approach something like this. So a lot of your graphs, when you got to the very last one where I asked you to take f of x divided by g of x, had kind of this situation going on. So if I looked at this equation here, first of all, we just decided dividing by 0 doesn't work. Well, whenever that happens, whenever we have a certain value that's not going to work for our function, a lot of times we'll call that an excluded value. So in other words, if I'm looking at this expression or equation here, I know there's going to be a value that's not going to work. It's going to be undefined. And for right now, as far as this equation, that's when 5x plus 6 is equal to 0. So I would say my excluded value for this equation would be negative 6/5. Now, in terms of the graph, what did that tell me when you guys were doing your graphs the other day? Which one, horizontal or vertical? Yeah. So in terms of the graph, we decide, okay, well, if that's an excluded value, if that's undefined, when I start graphing, that would really be a vertical asymptote. And when I make my graph, I would mark that vertical asymptote at negative 6/5. But we also said that we have horizontal asymptotes that were going on. Do you remember how we made that decision on where the horizontal asymptote was? This was kind of a new idea on Monday. And the horizontal was when we're looking at the long run.
Just values of
Yeah, we talked about it. We're really looking at really large values. Not that this doesn't factor in at all, but with really large values, that adding 4 and adding 6 doesn't factor in as much. So ultimately, we started looking at, okay, well, what's this if I simplify? So for this problem, x over 5x would give me an asymptote, a horizontal asymptote at 1/5. Because if you looked at that graph and the really large values, it's going to look like this horizontal line at 1/5. And then if I ask you to make a sketch from there, well, our sketch would include those two asymptotes. So I have one at -6/5, roughly in here. And I have a horizontal asymptote just above the x-axis because it's at y equals 1/5. And then all our graphs had the same shape. We had this kind of curve back here, and in the long run, we got close to the asymptote, so this kind of curve here. So if I asked you to make a sketch, that might be what our sketch looks like. So using that idea of we can't divide by 0 gives us an excluded value, but in terms of the graph, it tells me the vertical asymptote. And then when we look at the really large values, we know the horizontal asymptote is going to take on whatever I get when I simplify our largest exponent terms. So keeping that in mind, here's what I'd like you to do. Now, I'd like you to do this without using a calculator, without using decimals, but you will need some paper. So I'm going to give you two graphs here, or two equations, I should say. And what I'd like you to do is I'd like you to sketch both of these equations, keeping these ideas in mind here, the ideas of our vertical asymptotes, the ideas of our horizontal asymptotes. So here are the two equations that I'd like you to sketch. The first one is the equation y equals 2x minus 3 over 2x plus 3. The second one is y equals 2x minus 3 over 2x minus 3. Included values that might lead to an asymptote. I'm just doing a sketch, so once you get your asymptotes like this, then you're going to get the shape. All right, let's move into our groups, if you would please, and compare those graphs you just came up with. Again, no technology yet, just comparing what you put down initially.
No, I know it's not right. I know it's like that one.
Okay, now that you've done a comparison, what I'd like to do is let's go and enter it in, either into your calculator or if you want to use Desmos, one of the two. But enter those two equations in and see how their graphs compare to what you thought they were going to look. So now you can go ahead and use some technology to see what those graphs are going to look like. Remember, when you enter in the calculator, you have to put parentheses, like do parentheses around the 2x minus 3, and then parentheses around the 2x plus 3.
It's the same thing.
Negative,
So because it's minus 3, is that being used?
well, the whole entire term would have to.
But this one's minus 2. Like, that first one's like.
Oh, I see what you're saying. Well, if you, it is the minus 3 that's going to make it. Not minus 3 alone, but the fact that. I'm sorry, I just found out value and it's
Like where on the?
one of the that topics is like.
Oh.
So that's minus 3 plus 3. That's why it ended up being on.
So it says you cannot do.
Right, most of the time we've had these two. The whole would happen is you'd be starting with the value.
I don't understand.
By the top, it's exactly the same on the bottom. The next value, say it's 3 values. Well, you're gonna. Any surprises here? Any surprises when you made your graphs? Is anybody surprised by this graph? Probably not. You may have had a little bit of a surprise with it, but asymptote wise, hopefully that wasn't too bad. What was our vertical asymptote? According to this equation? Negative 3 halves. So over here, that's where our vertical asymptote should have been. negative 3 halves, not very straight lines. Where was our horizontal asymptote? Y equals 1 because we had 2x over 2x there, so that would simplify to 1. So our horizontal asymptote should have been f positive 1. So those two facts hopefully weren't surprising. Was there something a little different about our graph at that point? This group identified something that was a little different. What was different about it? What do you guys think?
It's like
No, on this first one here.
oh, it's like reversed.
Yeah, most of the ones we've done, we've had the graph on this side, we've had the graph on this side. This one was slightly different because they were in those opposite locations. And the reason that happened was partially at least because essentially I started with the same value here, and then I subtracted 3 from it. Down here I started with that value of 2x again, but now I added 3 to it. So I'm kind of doing opposites of one another, which is going to, in the positives at least, give me a little different situation. And then over here in the negatives as well. So that's kind of where we ended up with some different locations. If you're not sure, just pick a value. In other words, say I put in 5 here, see where that 5 ends up being located. If it's in this part, I know the other part had to be over here. If it had to be over here, then the second part's going to be down here. So nothing too shocking though on that one. We're a little bit surprised on the second one. What was the graph of the second one? Yeah, it just looks like a line, right? Okay. How do we get a line here? Okay.
Minus 3 divided by itself is 1.
Yeah, if we looked at trying to simplify this, if I have the exact same thing on top as I do on the bottom, then it just equals 1. So really we're looking at the graph of y equals 1. However, are there any excluded values here? Are there any values that really I shouldn't get an output for? Which would be when x is what?
3 halves.
Right, when I have that equal to 0, because I couldn't have 0 divided by 0, and that would be when x is equal to 3 halves. So I've got this line here, but I've got one value that doesn't work. Does that mean I should have an asymptote there for this one? No, because it doesn't take on the look of 3 halves. It still looks like y equals 1, but I can't have a value here. So how do I represent on a graph when I don't have a value at a certain point? It's open, good. So at the point 3 halves 1, or about right here, I really should have an open circle there. And then after that, everything is really y equals 1. So when simplifying could happen, and in this case, everything was simplified down to 1, it changed the type of graph that I was looking at. Well, because that simplifying changed things so much, it's really important that we know how to simplify these fractions and these rational expressions. And that's really going to be our goal for what we're going to do next is, okay, how do I actually do some simplifying when I have situations like that? So here's what I'd like you to try with your group members. And hopefully you can see those. I've got 8 different expressions. For each one, I want you to see if you can simplify them, first of all. The second thing you're going to do is list any excluded values. In other words, is there anything that actually would not work in this? Okay, for instance, the first one's not too bad. We'll do that one together. X squared over x squared, we know simplifies to 1. But there is an excluded value. What value would not work for x here? 0, because I can't have x squared equal 0. So I want x to not equal 0. So that's the kind of thing I'm looking for. Now, not all of them will be simplified to 1, but simplify them as far as you can, and then list any values that x could not have for a value, because it would be an excluded
So really, it's just.
Those are parts of that extra confidence.
Then it would just be 5 of them.
Yeah. I like getting and so. I can't do a straight from that.
I'm just saying, like,
I wanted to. No,
or what else? I'm gonna
This really for like one. Well, you separate that.
nice to
So you get negative one because it's positive and the x divided by negative, and then you get negative.
H squared. That's not good. That's one of them. I feel like
So
times two.
so after you multiply it out,
Yeah. Could be one. Then you have plus negative 4 divided by 2.
How did you do
It would be like 2:30. Yeah.
I
I'm gonna go back to my thing where I like back.
If you multiply it out, you get 9x.
That plus one, my. Yeah, that's my plan.
You just multiply across, like 9 times
You can do.
I think.
Yeah, you can do
Then I have a different one.
it.
Look, it's good
The first part basically goes away.
I don't think there is.
Which one are you talking about?
Oh, it's the back.
I should have been back.
Yeah.
Well, I mean, if you multiply 8 in the top, it just be 0 in the
You know how
middle.
you say numbers can be
Okay.
so like with this, you find out.
You have to 0 and 0.
Okay, so like basically, so basically, all you have to do is. Don't literally
Oh my God.
So if you plug in -6,
Some things are gonna have more than one.
I see.
When you did,
I don't know what works with the light. Yes, I know.
Oh,
what happened on C?
100%.
You can like just get rid of. And you can make that one.
Oh, yeah, X over 2 over X over 2.
Yeah.
So could I have a situation like that? Yeah, where I would have multiple. Yeah, so since it's in fact, that's actually better.
Wait, if you had to do that, how would you do this?
And get back into that.
So you can't
This is one entire thing. So unless they happen to be the exact same one. we couldn't Yeah, 2m minus 5 over 3m minus 1 is really an answer.
it's hard.
And that's kind of our next step, is figuring out, okay, what do I do with that?
I don't-
Because the N minus 2.
So you can't really use it.
When you guys did part B, how'd you get your answer?
I'm doing it the long way. No,
So you
no.
got x cubed over 3x squared,
Okay.
and then the
Look, I know,
get
I
x
know
cubed
that
Okay, because,
N is not yours.
so you can like cancel them out.
okay, all right, so, and you're right, that's our simplified. Now, here's my follow-up, were there any
The
excluded?
answer is N is not equal to
Yeah. Because I know sometimes, like, that wasn't.
If I just give you that final answer, that's over 3, that's a problem with that. You're right, that was your simplified answer, X over 3. Is there any problem with X over 3, like, is there any how you simplify by 3? No, that would be okay. But, if we go back to our original one, would there be a potential problem? Correct. 0, right, because if X happened to be 0 at the beginning, you wouldn't have been able to do that simplified. You would have had to try to divide by 0. So even though our final answer may be something that's okay, you always got to go back to the original and see if there's any difference.
This is my house.
I have no idea.
It's an expression of.
Well, how would they do this? Yeah,
Is the bottom up?
You don't got to spread this one.
I got that. I got that it's legal. I got that it's equal to 2n minus 4.
I got that one.
2n minus 4. That's what I got. Well, you know that it's the square root of 1, so then it's just 2 times n minus 2.
It's like you have 6x squared.
Yeah.
So what you were thinking, right?
X would not be.
You can just cancel them out, because n minus 2 squared, n minus 2 is 8.
Okay, a couple more minutes and we'll talk about, what you came up with here. Again, some are a little more simple than others.
I think it's 2 parentheses n minus 2.
we have to.
Yeah.
That's it. So X cannot equal.
Wait, and then it would be.
Yeah, losing more. And what you want to do that part.
Yeah.
I'm like,
I got that intangible 1/4 of 2.
Yeah.
Oh wait, no, sorry. 3 halves.
It's not.
It's not it's really close to low limit, except I got an intangible 1/4 of 3 halves.
You're like sharp when you mind
But like making that.
also a lot of things are similar in activity.
It's
not easy to do,
Or
right?
it's just a little bracket thing.
I thought I'm trying to make sure.
Oh, sorry, we want 1 over.
But it's like right.
So if you like it.
It's only like 42.
Yeah.
It's like 1.
All right, let's start, first of all, just with what your simplified answer was, and then we'll come back and talk about the excluded value. So, I'm just gonna kind of go around from group to group here and see what you ended up with on the different expressions. Let's start with, group in the back for part B, which have, I don't need the excluded value, but just what your simplified form.
X over 3.
X over 3, okay? Good. Can you briefly tell me how you got there?
Well, X, divide by x, and then that equals 1, and then the other x divided by x equals 1.
Okay.
So that leaves you with x divided by 3.
Right. Okay, so that might be a good way of thinking about it. Some of you multiplied it out, nothing wrong with that. You said x cubed over 3x squared, and then you simplified from there. And that would have worked as well. All right, part C, this group here, what'd you get for your simplified into?
We had x plus 5 over x minus 1.
Right. And how'd you get there?
We just got rid of the first part, so it's equal to 1.
Okay, so kind of the same idea here, except now it was x minus 2 over x minus 2. And since the entire term was the same, that we know that really gives me 1 there. Okay, what about for part D? Back here, we can get to part D.
We got x equal, or just 1.
Just 1? Okay, and how did you take that one?
Well, you can either cross cancel them and that give you 1, or you can multiply it out and get 9x for the 9x.
Okay, so if you multiplied it, you end up with the exact same terms, or you may have remembered there's kind of a shortcut where if I can divide anything on the top by anything on the bottom, even if it's across, you can do some canceling on that as well. But yeah, we're going to get a positive 1 there. All right, what about for E? Look in the middle back there.
H times J.
Okay, and how'd you get there?
Once the H is cancel out, I know that's not the one on bottom.
Okay. And it was all multiplication, so I could make that step there. Okay, good. Some of you multiplied it out and then simplifying, and that was fine as well. All right, then it got a little bit trickier on some of these, but let's see. F, this group here. What do you put?
I got 2m minus 5 over 3m.
Right, and how'd you get there?
That's the m plus 6.
Okay, we've got an m plus 6. That's exactly the same as what was on the top, so we can do some canceling on that one. All right, then the last two. I heard some discussion on this. Most of you figured out, okay, I got 6 over 3. So I know I got 2. Then I've got n minus 2 squared over n minus 2. Maybe one way to think about that is I've got this. N minus 2 times itself over n minus 2. Which means I could do some canceling because n minus 2 over itself is really just 1. So we could write it as 2 times n minus 2 or 2n minus 4 for our answer there. What about the last one? Can I do any canceling here? Yeah, the 3 minus 2x's. So what am I going to end up with? Yeah, 1. It doesn't just totally disappear. We've got 1 over 4x minus 1. All right, so those are our simplified ones. Now, we have to be a little bit careful when we do the excluded part because when we're looking at excluded values, we're really thinking about the original function. We're not thinking about these simplified forms that we came up with because sometimes the simplified forms may not have excluded values, but the original one actually did. For instance, x over 3 here, well, there's nothing wrong with that. I can divide anything by 3. However, if I go back to the original, I had this situation on 2 of the fractions. So what's my excluded value for that one? What could I not have for an x value? 0. So I do have an excluded value, and that is that x could not equal 0. Because if x were equal to 0, I couldn't have canceled in the first place. I couldn't have put 0 over 0 and said that was 1. Same idea on C. I definitely have x equals 1 as an excluded value. What's the other one, though? 2, because in the original I had x minus 2. So x could not equal 2 or x could not equal 1. For D, it was just x couldn't equal 0. Even though we canceled those out, it couldn't be equal to 0 originally. For E, h could not equal 0. That's an excluded value. For F, well, we know this one couldn't work, so it couldn't be negative 1/3. What else could not work? Negative 6. Then for G, it was just 2. And then for H, we had a couple of them. X could not be 1/4 because of this, but also this would not work as well. So that was what, 2/3 or 3/2? All right, so those would be our excluded values. Now, the nice thing about all these were in a form where it was somewhat, at least, easy to figure out what things matched and what we could cancel. Sometimes that's not the case, though. So I've got some true or false here, and I want you to think about it. So for each one, I want you to try to figure out, okay, is that a true equation or is that a false equation? So look at those 5 equations, and then we'll see what you think. Now, as you're deciding they're true or false, we're going with the assumption that we're not dealing with an excluded value. Okay. Okay, the oldest person in your group. Figure out who the oldest person in your group is. All right, the oldest person in your group, that you're the spokesperson for your group members. So for the first equation, if your group said that was true, you're going to stand up. Oldest person wins. So 4x over 4 equals 4. If you think that was true, stand up. All right, that one was unanimous. I'll come back to that here in a second. If you said the second one was true, remain standing. That one was unanimous. If you think the third one's true, remain standing. Give in the peer pressure there. Looks like we got false. Okay. Third or fourth one, if you said that was true, stand up. By the fourth one, I mean this one here. Okay, I got 1, 2, 3, 4 truths and 2 falses. Okay. Remain standing if you think the last one is true. Stand up. That one was unanimous. Okay. All right, let's see how we did. Now, what might be a good way to check it and see? Substitute something in, okay? As long as it's not an excluded value, I can substitute it in. So if I put 3 in, for instance, 4 times 3 is 12, divided by 3 is 4, seems to work. If I put 5 in, 4 times 5 is 20, divided by 5 is 4, seems to work. And you were right, that one was a true statement. Second one, we have the exact same thing over itself. We already know that's going to be equal to 1, so that's true. The third one, everybody said false on that one, but shouldn't I be able to, you just said x over x is 1, so x over x is really 1 here, isn't it?
because you're adding them, so that's one term.
Yeah, if we actually check the value there, again, say I put 5 in, for instance, 4 plus 5 is 9, divided by 5 is not 5. Okay, and that's a good way of thinking about it, is this is really an entire term. So unless that entire term matches what's on the bottom, I can't do it again. So that one was false. All right, we have one that was giving us a little variety of answers. For those of you that said true, is this what you did? I got x plus 3 over x plus 3. You just did it. How come you did it? Or said I can't do it, I just did it.
But you can't write that.
Why can't I do that? All right, listen, Kenzie said I can't do that. How come I can't do that?
Because it's added.
Right, we've got addition going on here. So I can't just pick and choose what I want to have matched. Again, a good way of checking it is put a value in there. If I put 0 in, for instance, that would be 3 on top, that would be 3 on bottom. 3 over 3 is 1, but 0 squared would be 0. That wouldn't match. So those of you that said that was false were correct on that. Does that mean I can't cancel the x plus 3's over here now then? Now I have the exact same terms plus what's happening on the top. Yeah, we got multiplication, and with multiplication I can start doing some simplifying. So that one was true. So big idea here. If I'm going to simplify, I've got to have it in a multiplication form, or I've got to have it in factored form. And that's going to be our next step is, all right, well, if they don't give it to me in that form, I've got to factor it first before I do any canceling. For instance, if I looked at this first expression here, first of all, I would notice, all right, well, it's not in factored form, so I can't just start picking and choosing things. And please don't do this, because I know it's going to happen at some point in time. People are going to start doing this, they're going to do this, they're going to say it's 6x. But Kenzie just said I can't do that, so I can't do that. Even though I did it again. So I'm going to have to factor instead. So if we looked at that first term, x squared plus 6x plus 9, I can factor that into x plus 3 and x plus 3. What can I factor the denominator into? Yeah, we've got a difference in squares, so x plus 3 and x minus 3. Now, just factoring it doesn't guarantee me I can cancel anything, but sometimes I can. What can I do in a canceling now? Yeah, I've got some x plus 3's here and here. And so my simplified answer for this would be x plus 3 over x minus 3. Which means I can cancel the x's, right? And I can cancel the 3's.
No, you can't do that.
No, can't do that. Keep trying, but won't. That would be our simplified answer, okay? All right, so why don't you guys try the next one? Try to factor the top, try to factor the bottom, and then see if we can do any simplifying or cancel.
I lost it.
Oh, yeah.
All right, you should have those as your factors, 2x minus 5 times x plus 2, 3x plus 1 over x plus 2, which means I can do some canceling here with my x plus 2s. So this should have been your answer for that. Okay? Now, what if I gave you that and asked you to simplify? If it's the exact same thing, do I have to factor? No. So if the entire numerator matches the denominator, well, that's just like any other time that happens, and I would just say that's equal to 1. So don't always jump right into factor. You can always check and see, okay, do I happen to have, now it's got to be everything that matches, but do I happen to have some that match on the numerator and denominator? All right, so that's kind of like our next process, next thing that we're going to be working on. Is dealing with stuff like that. And we're going to throw in some multiplication, division, and eventually addition, subtraction with those. Okay, so that's kind of what's coming up on Friday. All right, with the time we have left here, two things to take care of in this order. The first thing is finish up your posters for Monday. Okay, so they're back in the back there. You'll have to find your group's posters. Materials are up here. Second thing would be those problems are going to be due on Friday. Okay, so you can start working on those. The first priority is the poster, taking care of the poster. They're on that back seat there.
But if we haven't